Okay, today we will discuss about ideal gas law. It consists of only 22 slides and it will take less than 20 minutes. Okay, what to expect? Skip natin yan. Okay, the ideal gas equation of the state. The equation that relates to pressure, temperature, and specific volume of the substance. Ayun, madidiscuss dito yung mga relationship ng temperature, pressure, and specific volume. Okay, Boyles, Charles, and Galius have observed that pressure of gases is inversely proportional to their volume, and the volume of gas is proportional to its temperature. We have formula of P is equals to R times T over V, or PV is equals to RT. The relationship ng pressure is directly proportional to temperature, while it is inversely proportional to its volume. Ideal gas constant. Ito yung gas constant for each substance or for each ideal gas. Where the formula is R is equals to Ru, or the universal gas constant, all over M, or the molar mass or molecular weight of the substance. The unit is in kilojoules per kilogram Kelvin, or in kilopascal cubic meter per kilogram Kelvin. Ang universal gas constant natin is 8.31447 kilojoules per kilomole Kelvin, or same lang, 8.31147 kilopascal cubic meter per kilomole Kelvin. And then ito naman yung other derivation, yung last three derivation niya in English units. Tapos ito, meron tayong mga example of some substance. For example, the air has the air has gas constant of 0.287 kilojoules per kilogram Kelvin, while the helium is 2.0769, argon is 0.2081, and nitrogen is 0.2968 kilojoules per kilogram Kelvin. Okay, so ideal gases, yan, mga example ideal gases natin is the air, and yung nitrogen gas, carbon dioxide, helium, yung mga noble gases, oxygen, ayan. Pero meron din yung tanong, is water vapor an ideal gas? Water vapor is considered as ideal gas if the pressure is below 10 kilopascal. Kung mababa ang pressure at below 10 kilopascal, it is treated as ideal gas. Pero pag high pressure, hindi na siya tinatanggap as ideal gas. And also, for air conditioning application, kung ambient temperatures lang naman yung consideration when it comes to water vapor, it's considered as ideal gas. Pero kung matataas tayong temperature like steam power plants, ideal gas relation is not accepted. Gumagamit na tayo dyan ng water property table or yung steam table, which we were able to discuss that before. Molar mass, ito naman yung mass ng 1 mole of substance or 1 mass of 1 mole of ideal gas in grams, or 1 mass of 1 kilomole of substance in kilograms. Ang unit niya is kilogram per kilomole, or equivalent to grams per mole. Parehas lang siya. The mass of a system is M is equals to Mn. Ito yung formula natin, where the mass is equals to molar mass times the number of mole of the ideal gas or substance. Meron tayong sample problem dito. What is the mass of 3 kilomoles of diatomic nitrogen compressed in a tank? Given natin number of moles is 3 kilomoles. Required natin is mass, or the m in kilogram. Formula natin is small m is equals to mn. So direct substitution natin, 28.97 kilograms per kilomole times 3 kilomoles is equals to 86.91 kilogram. Saan ko nakuha yung 28.97 kilograms per kilomole? At 3 kilomoles lang ang given natin. We use the table. Gagamitin natin yung table sa appendices ng Sengel. Okay, pakita ko na din. Okay, ito yung makita natin dito sa table A1. Ang table natin, ito yung mga substances, which are the gases, chemical formula, the molar mass, gas constant, and critical point properties. Okay, dito tayo magpo-focus sa molar mass and gas constant. For air, wala tayong chemical formula since it is a mixture. Ang molar mass natin is 28.97 kilogram per kilomole. And then yung gas constant natin is 0.2870. Kung i-check nyo dito, makukuha natin yung gas constant, universal gas constant, divided by molar mass. Ito yung lalabas na values na gas constant. Nandito na. And then the ammonia, NH3, ito yung molar mass niya and gas constant. Then benzene, butane, carbon dioxide, carbon monoxide, hanggang water and xenon, alphabetically arrange siya. And then dito naman tayo sa table A2, ideal gas, specific heat of various common gases. Ito magagamit natin ito, or hindi naman natin i-compute na, hindi natin isasali, pero sa adiabatic ideal gases. Ideal gas, ito yung gas formula, gas constant. Ito yung kanina sa taas, gas constant. And specific heat at constant pressure and specific heat at constant volume. Yan, magkaiba yung specific heat nila at constant pressure and at constant volume. And then itong K is the ratio of specific heat Cp all over Cv. Ito yung lalabas pag kinuha natin yung ratio nila. Okay. Doon natin nakuha kanina yung 28.97 kg per kilomole. What is the gas constant of a gas with molar mass of 32 grams per mole? Ito naman, meron tayong unknown gas, pero may molar mass siya ng 32 grams per mole. Ano yung nahanap natin? Gas constant. Ano ba yung formula ng gas constant natin doon? Kanina. R is equals to RU all over M. Given yung M, which is 32 grams per mole, 32 grams per mole is equivalent to 32 kilograms per kilomole. Parehas lang yun. Required is the gas constant R. Ito yung solution natin. RU over M, which is wherein the universal gas constant, it is always constant. The universal gas constant is 8.31147 kilojoules per kilomole Kelvin. Nasa calculator nyo din yan. Kung magamit kayo ng scientific calculator, shift constant, 27. Ayun. 8.13447 kilojoules per kilomole all over 32. Pinakita lang dito na 1 kilomole per kilogram is equals to, sa baba, yung denominator, pinakita lang dito na parehas lang yung 1 grams per mole and 1 kilogram per mole. And then 8.31147 divided by 32 is equals to 0.25983 kilojoules per kilogram Kelvin. Ito yung ano natin, basic formula natin ng ideal gas equation of the state. PV is equals to MRT. Pressure times volume is equals to mass times ideal gas constant times temperature. And then ito naman yung pangalawang equation, given, kung ang given lang ay number of moles, gagamitin natin yung universal gas constant. Ito naman, meron tayong V dash, molar specific volume, or kilomole per kilogram, kung yun ang unit niya, kilomole per kilogram, molar specific volume. Ang gagamitin naman natin universal, ang R natin ay universal gas constant. Okay, meron tayong isang sample problem dito. What is the mass of the air in a room whose dimension is 4 by 5 by 6 meter at 100 kilopascal and 25 degrees Celsius? Okay, ano ba yung mga given natin? Ang volume natin is 4 by 5 by 6, which is equivalent to 120 cubic meter. And then ang pressure natin is 100 kilopascal, temperature is 25 degrees Celsius. So, gamit tayo ng formula, PV is equals to MRT. Ang hinahanap natin ay mass. So, we will get M is equals to PV all over RT. 100 kilopascal yung pressure. Then, ang volume is 120 cubic meter. And then, saan natin nakuha yung 0.287 kilopascal cubic meter per kilogram? Ito natin siya kukunin sa table A1, which is the molar mass of air. And then we have 298 Kelvin. Makita natin dito, we use 298 Kelvin, not 25 degrees Celsius because unit of uniformity yung kino-consider natin. 25 plus 273 is equals to 298 Kelvin. So always use Kelvin. And then ang mass natin is 140.3 kilogram. Okay, paano naman kung meron tayong dalawang state? Ano yung ideal gas property niya from state 1 to state 2. Meron tayong P1V1 all over T1 is equals to P2V2 all over T2. Kung meron tayong changes in state. Ito, marami tayong mga types of ideal gas processes. For example, isobaric gas process where pressure is kept constant, kung saan change in P is equals to 0. Makita natin sa illustration that before heating, at a constant pressure after heating, nag-expand yung volume natin. So, since change in P is equals to 0, from our original formula, na-cancel yung P. So, we get V1 all over T1 is equals to V2 all over T2. And then, dito naman sa kabila is the isochoric process. The volume of the system is constant. So, na-cancel naman natin is yung V1 and V2. We get P1 all over T1 is equals to P2 all over T2. Ito yung example. Since rigid tank siya, nag-add tayo ng heat. At the final state, parehas pa rin yung volume pero tumaas ang pressure. Then, ito naman ay isothermal process. Ang temperature of the system kept constant. There is no change in temperature but there can be changes in pressure and volume. For example, nag-add tayo ng work, di ba? Wala tayong in-add na heat pero nagkakaroon tayo ng changes in pressure and volume. So, we got the formula of P1 V1 is equals to P2 V2. And lastly, adiabatic process at a constant heat or there's no change in heat, no heat added. Ang formula natin ay PV raised to gamma, wherein yun yung pinaka-constant K natin. The gamma is the ratio of Cp all over Cv, or specific heat at constant pressure, all over the specific heat of constant volume. So, ano na lang, to make it easier, ang kukomplete na lang natin is isochoric, isobaric, and isothermal processes. At yung example, at a pressure of 405 kilopascal, the volume of gas is 6 cubic centimeter, and assuming the temperature remains constant, what will be the new volume at 4 cubic centimeter? So, ano ba mga given natin? P, 400, P1 is 405 kilopascal, ang V1 is from 6 to 4 cubic centimeter, ay hinahanap natin is change in pressure. So, sabi dito, the temperature remains constant, so ang process natin is isothermal. This because temperature remains constant. Kung pagbabasihan natin ideal gas equation, ito yung P1 V1 all over T1 is equals to P2 V2 all over T2. Since constant yung temperature, makakancel yan. So, we get P1 V1 is equals to P2 V2. Since P2 yung hinahanap natin, gamit tayo ng algebra, P2 is equals to P1 V1 all over V2. And then, direct substitute natin yung mga values. 607.5 kilopascal. Makikita natin, bakit hindi ko na-convert itong 6 cubic centimeter and 4 cubic centimeter? Kasi supposedly, kung gantong metric, dapat ang pressure is in kilopascal, volume is in cubic meter, and temperature is in Kelvin. Diba? Dapat ganon. So, hindi na natin binago kasi ratio and proportion lang naman siya. Pero pagdating sa temperature, kailangan nyo siyang baguhin pag temperature kasi nag-add tayo ng 273, hindi siya cancelable kasi addition. Okay, a container is containing at 5 liters, the gas collected is 100 Kelvin, then allowed to expand at 20 liters. What must be the new temperature in order to maintain the same pressure? And yung given natin, change in volume is given, V1 and V2. Initial temperature is 100 Kelvin. What is the final temperature? Ito yung formula natin at constant pressure. V1 all over T1 is equals to V2 all over T2. T2 is equals to V2 T1 all over V1. Then direct substitution, we get 400 kelvins.